starting 2.2, which is properties of quadratic functions. So all of chapter 2 is quadratic. We're still working with those functions. And by the end of today, you're going to be able to define, identify, and graph quadratic functions and the axis of symmetry. So actually a lot of today is going to feel like review of some of the stuff that we did yesterday. We're just going to be extending that. So the first thing we're going to talk about is the axis of symmetry. Okay, so symmetry is a word you might remember from geometry. Okay, if they are symmetric about a line, it means you could fold, in this case, the parabola over that line, and it would be the same on both sides. Okay, so the axis of symmetry is a vertical line that goes through the vertex of a graph. It is a vertical line that goes through the vertex of a graph. And because we're doing quadratic graphs, we know that in this case it is going to be a parabola. So if it is a vertical line, do any of you remember what the equation is going to look like? It's a vertical line. That's going to be true for a constant. So I'm just going to draw an example. Here's y, here's x. So if I had a vertical line, okay, it goes through what axis? It goes through the x-axis. So the line is always going to start with x equals. If it is a horizontal line, that would be your y equals or your f of x equals. Okay, so we are going to draw a parabola together. And we talked yesterday about the center of the graph. The center of the graph is what point? The vertex. And that's why we put it in the center of our table yesterday. So because the axis of symmetry is also in the center, that means that your axis of symmetry is always going to go through. Your axis of symmetry is always going to go through what? Which is your axis of symmetry always go through? If it's in the middle, it's always going to go through what? Yeah, so it's going to go through your vertex, right? Alright, so we are going to we're going to draw this together. Alright, so we're going to draw a parabola. Not a parabola, a parabola. Okay, and then we have this special point at the center of our parabola called the vertex. Do you guys remember what variables we used for the vertex yesterday? Yeah, so your vertex is HK. So we just learned that the axis of symmetry is going to go through it. And notice that your axis of symmetry, we notate that with a dashed line. So the dashed line indicates that it's not actually part of this function. It's something else that's on the graph. Okay, and in this case, It is a line, and it's going to have the form x equals, and when you're writing a line, you're always going to have x equals. Where is this going to hit on your x-axis? The arbitrary value. Yeah, it's going to hit at h. So your equation of the line is going to be x equals h. Okay, so this is the equation of the line. So I'm going to put EQN for equation. Equation of the line. For the, and then I'm going to abbreviate axis of symmetry as AOS. Axis of symmetry, AOS. So if you want to write it out, you can. Okay? Okay, and then what's true is that the axis of symmetry is always going to go through the vertex. I'm just rewriting what you guys already wrote so that you can see it. Alright, so some of you may have noticed that I underlined the word line. Oh Lord. There we go. That I underlined the word line here. And that's because your axis of symmetry has to be written as an equation of the line. So I'm going to be stressing that a lot today. The axis of symmetry, so the AOS, will always go through the x-coordinate of the vertex. That's always going to happen. Okay? If you do not have the x equals your h value, then something went wrong. Okay, because we know that the x-coordinate is the h value. The x-coordinate is the h value. So time to put this into practice. For example 1, we have to identify the axis of symmetry for the graph of, dun dun dun, and then we're going to do 2 examples. So we don't have to graph for example 1. Okay, we just have to find the axis of symmetry. Okay? So, we have to think back to yesterday. Part A, do you guys remember what form that's in? Yes, vertex form. Okay, so if the equation is in vertex form, okay, then to find the vertex, remember you do H and K, but it's the opposite of what you see. This number out here does not affect this value. Okay, so if it's x plus 5, what's my h value? Negative 5. So the vertex is negative 5, negative 8. My axis of symmetry always goes through the x-coordinate. So my axis of symmetry is going to be x equals negative 5. And really, when you're doing your homework, you won't even have to write out the vertex. I'm just trying to show you what we did yesterday, right? We picked out the vertex. It's going to be your x value, okay? Now, when you write this, I'm going to stress this again, okay, you need the x equals. So you need x equals for the axis of symmetry. Okay, and the reason why I'm stressing that so much is that can be something small that people forget on a quiz. Okay, so we have to make sure that we have that x equals. And the reason why is because the axis of symmetry is a line. So if you just had -5, that does not represent the same thing as x equals -5. Okay, so you have to have that notation. Okay, notation is something big that we work on in honors. Notation and explanation. And we will do both today. All right, now for B, this is not in vertex form. Do you guys remember what the form is called? Starts with an S? No? Standard. The slope intercept will be for linear. So this is standard form. This is okay, so if it's in standard form, think about how we found the x-coordinate of the vertex yesterday. Rashawn, do you remember how we found the x-coordinate yesterday? No? Emmy? Phone a friend. What friend do you want to phone? All right, Dane, how do we find the x-coordinate? You didn't dream about that during your nap yesterday? All right, let's phone Brianna. Brianna, you remember?
Not well, no.
Maya, help us out.
You do the opposite of B over 2.
Great. Okay, so remember you do the x equals the opposite of b over 2a. Now is it ringing a bell? Now you guys are going, oh yeah. Oh yeah. Okay, so this is how you find the x-coordinate of the vertex. This is how you find the axis of symmetry. And look, it even has the x equals. So now we have to find the b and we have to find the a. And then your b value, you're looking for the x term. If there's no x term, your b value is 0. What if there was just one? What if there was just an x and there was no number in front? Would you guys know what the b value is in that case? 1. Okay, so it's only 0 if you can't see it. So b equals 0, a is 1. So this is going to be x equals opposite of 0 over 2 times 1, which we know is 0. So your axis of symmetry is x equals 0. And again, make sure you have the x equals. You guys look pumped that it's our first 5-day week together. We're all excited. We're hanging in there. Okay, so today we're going to talk about the quadratic equation in standard form. So that is f of x equals ax squared plus bx plus c. And then there are certain things that you can tell from that equation. So we're going to go over these properties. Do you see any more time with part B? Speak now or I'm going to move it up. Alright, so the first thing we can tell is which way the graph opens. So it opens upward when a is greater than 0, which means when a is a positive value. Okay, it opens downward when a is less than 0, which is a negative value. Okay, so we're talking about a, which is the leading coefficient of standard form. Okay, your axis of symmetry, we actually just did that. So it's x equals the opposite of b over 2a. When it's in standard form, you are going to use the opposite of b over 2a. Yep.
What if the A equals 0? There's no...
So for this it wouldn't, because if this was 0, it would be a linear function.
Oh.
And then you wouldn't even have the parabola.
Okay.
Yep. Okay, and then the y-intercept, you guys might remember this. Your y-intercept is the value of c in your equation. Okay, so if I plugged in 0 for x, this would become 0, this would become 0, and then I still have plus c. So 0 plus c is just c. When we write our y-intercept, we're going to write it as a point. So the point is 0c. And this actually fits really well because remember we talked about how c is the constant term. Okay, and you can always check this by plugging in what? What could we plug in to find the y-intercept? How could we find the y-intercept?
Plug in x.
Plug in for when? What would we plug in for x? What would x equal? 0. Yeah? Okay, so you're going to plug in x equals 0 to find the y-intercept. Okay, so you can always do that because x is going to be 0. Alright, now the vertex. The form of the vertex that they write in your book might be a little bit confusing, so I'm going to go over that step by step with you. So the first part of your vertex, think about what our x is. To find x, don't we do the opposite of b over 2a? Okay, so that is what we would denote as finding the x, the opposite of b over 2a. Okay, and then I'm going to use what Seth said to help us understand this next part. Right? He was saying how you plug in something for x. Well, if I plug this in for x into the function, it's like I'm doing f of that value. So I would plug in the opposite of b over 2a, and that's how I would find my output. Okay, so this is the notation that they use in the book. So like looking at that, we might get scared because there's a lot of letters together. But all this means is this is the output when you plug in negative b over 2a for x. Okay, so this notation just means this is the output when you plug in the opposite of b over 2a for your x value. That's all that it means. Okay, so you're going to find your x using the opposite of b over 2a. Whatever you get from there, plug it in. That will be your y. And that's what we did yesterday. All right, today, for example 2, we're going to have several different steps, okay? So in the first one, consider the function f of x equals, so I like to highlight, you can also just box this in. This is the function that we're using. F of x equals 2x squared minus 4x plus 5. Okay, and the first one says determine whether the graph opens upward or downward. Explain your answer. Okay, so we're going to have to say if it's upward or downward, and then explain your answer. And I'm going to help you with the explanations. So we want to make sure that we are being as specific as possible. So I'm going to help you craft those, okay? So we are going to write the explanation. We're going to start in question-answer form. So we're going to say which way the graph opens. Okay, and then to determine which way the graph opens, we're going to use, Rashawn, which value we're going to use to tell us whether the graph opens up or down? A. All right, so we're going to use our A value So if I'm looking at standard form, my A value is my leading coefficient, or that value in front of x squared. So in this case, Lizzie, what's our A value?
2.
Perfect. Okay, so we're going to say the graph opens upward, and then I'm going to be very specific about why. Okay, it's because the A value 2 is positive. Okay, so there's a couple things I want you to do. I want you to make sure you identify the A value. And then you have to identify if it's positive or negative. Okay, you could also, if you want to say the leading coefficient, you could, that would be another way you could word it. Okay, but we definitely want to identify the A value because we have multiple values here, right? And in some cases, multiple values are going to be positive, and we want to make sure we are explaining this as specifically as possible. So it's the 2 that tells us that it opens up because 2 is positive. All right, and then poor little B got cut off by the hole punch, so this is B. So for part B, we're finding the axis of symmetry. Okay, so the axis of symmetry is the opposite of B over 2A. So we're going to pick out our value for B. All right, and Jack, can you tell me what our B value is for this equation?
Would it just be 4?
Nope, but yes, -4. Good, okay? So you always want to take the sign that's in front of it. When we plug it in, it is going to be the opposite. Okay, and then we already talked about our A value, so our A value is 2. So now I'm going to do x equals the opposite of B, so the opposite of -4 is 4. Okay, and then 2 times 2. And again, stuff like this, I expect you to do mental math. Okay, so we know 2 times 2 is 4. 4 divided by 4 is going to be 1. And then when I write my final answer, I need to have the x equals. Okay, so anytime it's the axis of symmetry, your axis of symmetry must be an equation. And that's because it is a line. Okay, so just saying 1 does not mean the same thing. X equals 1 indicates it is a vertical line. Alright, so now let's look at part C. Alright, and then for part C, I told you how to find the vertex. Alright, so if you go home and you're like, oh, I forgot how to do that, go right here. It tells you exactly what you need to do. For C, we're going to find the vertex. Okay, we know that the H value, the vertex, is the axis of symmetry. So that's what we found in the last one. We found that X was 1. To find the Y coordinate, you're going to plug your value into the original equation. Okay, so the axis of symmetry, we just said that was X equals 1. What I'm going to do is, because I like to have these on the same side, is I'm going to write my f of x, my function, which is f of x equals 2x squared minus 4x plus 5 from the other side. I don't like to flip back and forth if I can help it. Alright, so we're going to plug it in. So if x equals 1, we're going to do f of 1. Okay, I want you to plug in 1, and I want you to use your order of operations. And then we're going to check and see how we did. So remember your order of operations, so do exponents first. Then you multiply. then you do your addition and subtraction. Alright, so you have to, before you can do the squared, you have to do 1 to the power of 2. So don't multiply first, you got to do exponents first, okay? So this would be 1 squared, which is 1. 1 times 2 is 2. Negative 4 times 1 is negative 4, plus 5. And then in my mind, I would do the 2 plus 5 first, which I know is 7. And then I would do 7 minus 4 to get my 3. So my y value would be 3. So we have to find the vertex. So the vertex is 1, 3. And when you write your vertex, it's going to be a coordinate. So just double check, make sure you put your parentheses on there, just like we have been doing. Okay, and then for D, you're going to find your y-intercept. So remember that the y-intercept is your C value. Okay, so you can substitute 0 for x in the original equation, or you can just look and see what your value of C is, which is 5. So your C value is 5, which means your y-intercept is 0, 5. Okay, so you're also going to write your y-intercept as a coordinate. Upper coordinate point. Keep it consistent. Okay, so your vertex is a coordinate, your y-intercept is a coordinate. And then for E, you're going to graph the function. You're going to make a table to show your points. So just like we have been doing, we're going to do 5 points. And then, Gwen, how do I start the table? Yep, where do I put it? Good, so I'm going to put my vertex in the middle. So that's 1, 3. I like to backline in there. Okay, and then, Danny, how do I decide what my other x values are going to be? Good. Okay, so I'm going to do 2 and 3, and then 0 and negative 1. Now remember, they should be symmetric about the y. So go ahead and plug those in, and then you can determine how you're going to graph this. So I didn't give you a scale. I want you to make your own graph. Okay, and I'm going to give you a couple minutes to do that. So that's exactly like what we did yesterday. Alright, let's see how that went. Okay, so just be careful if you are plugging some of these into your calculator, because if you don't tell your calculator exactly what to do in the correct way, it will give you an incorrect answer. So this is 2 negative 1 squared minus 4 times negative 1 plus 5. So negative 1 squared is 1, 1 times 2 is 2. Negative times a negative is a positive. So 2 plus 4 is 6, 6 plus 5 is 11. And then we know that if we choose the middle, those are going to be symmetric. Now for 0, guess what? Didn't we already find that? Yeah, this is the y-intercept. Okay, so that's your y-intercept. And then those should be symmetric as well. Okay, so what we're doing is we're plugging in 2, and then we follow the order of operations. So 2 squared is 4, 4 times 2 is 8. This is 8 minus 8 plus 5. So 0 plus 5 would be 5. Okay? Alright, now if I have to go up to 11, I want to think about what I want my scale to be. So all of my points here, 3 is my lowest point, the rest are going to be above that. So I can make this graph like low here. I can start my scale here. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Now, if you went by 2s, that is perfectly fine. Okay, I want you to decide how you want to graph that. Okay, so I'm going by 1s and I'm going by 1s. 2, 3. Okay, and then just label a couple of them in there. Alright, so I'm going to graph it. So negative 1, 11, 0, 5, 1, 3, 2, 5, 3, 11. And then remember you're connecting these with a curve. So sometimes I do like one side at a time. I like to make my curve there. Alright, now one extra thing you're going to do today is we're going to put in the axis of symmetry. So once you have your parabola, you don't have to compare it to the parent function because we're not doing transformations. Instead, we're focusing on the characteristics of the parabola. So we are going to put in our axis of symmetry. So to denote the axis of symmetry, you're going to put in a dashed line. It is going to continue along whichever your graph is. So we're filling the window, and then we're going to be labeling it. So this is x equals 1. Okay, so you're going to include the axis of symmetry on your graph. Okay, and it's a dashed line on your graph. Okay, the dashed line indicates that it's a special feature and not part of the function itself. Have any of you heard of an asymptote before? That's something we're going to learn about this year. Those are other special lines that happen on the graph. Okay, so for example 3, this is exactly like example 2. So I want you to consider this function and then complete the steps A through E just like we did in the problem above. So I'm going to let you guys do this. I'm going to give you a few minutes to do so. Okay, and in just a moment, we will check to make sure that you did part A and part B correctly. Okay, but I'm going to let you guys take the lead on this, and I'm going to come around and check your stuff. Alright, I want you to check your parts A and B with me. So for part A, you need to say that the graph opens downward because the A value -1 is negative. Or if you wanted, instead of saying negative, you can say is less than 0. But make sure that you have the A value in your explanation. And if you don't, we're just going to add it in there. Okay? So make sure you identify the A value. Okay, so you need to say that it's -1. Then for part B, you're doing the opposite of B over 2A. So the opposite of -2 is 2. And then if there's no number in front of x squared, it's a 1. Because there's a negative in front, it's a -1. So that's 2 divided by -2, which means your axis of symmetry should be x equals -1. And then one thing I want you to double check for is that you have the x equals. Okay, so make sure that you have those correct, and then you can proceed on. And don't forget your axis of symmetry on your graph. Once you're done, when you get out your graphing calculator, because I'm going to show you something cool today. I mean, I show you something cool every day, Bernard, but you're going to like this. you have your axis of symmetry, we're going to take that value for x, we're going to plug it into the original equation. So this is something where if you're using your calculator, you need to be careful about how you're entering that in. I highly recommend you do this with mental math. Negative 1 squared is 1. 1 times a negative is negative 1. A negative times a negative is going to be positive. So you should end up having negative 1 plus 2 plus 3, which is going to give you 4. So just be careful here. Make sure you do the exponent before you multiply. This should be a negative 1 here. Okay, so if you got 5, if you got 6 instead, it's because you didn't have the negative, you had the positive. So remember your PEMDAS. All right, your intercept should be 0, 3, your y-intercept, which is the same as your c value. You have the plus 3 here. And then that's going to go in the center of your table. Okay, what questions do you guys have for me on steps A, B, C, or D? Alright, so I'm going to show you how to graph this on your graphing calculator. Okay, so we're going to graph it and we're going to construct the table as well. Okay, so with your table, if you haven't done it all yet, at the very least, I want you to put the vertex in the center. Make sure you put the vertex in the center and not the y-intercept. Okay, and then like I said, I'm going to show you how to graph this on your graphing calculator. We can zoom out. I'm going to zoom out so you can see the whole calculator. Alright, so the first thing we're going to do is we are going to enter this into our y equals. Okay, so we have y equals, and then we are going to enter in our equation. Okay, so our equation is negative 2, negative x squared. For this, the negative has to be the negative button, which is here on the very bottom row. Do not put in the minus or else you will get a syntax error. Okay, it'll say there's an error and it will not graph it for you. Now for the x squared, you can do it two ways. You can either use the variable, the x, and then see how you have x squared on the side right here? You can do that, and it does it for you automatically. That's this button here. And then you can keep going, minus 2x, keep going. Or, after you enter the negative and you do x, you can do to the power of 2. The only difference is now, see where the cursor is? You're going to have to move that to make it next to it again, so you arrow over, and now you can enter in the rest. Minus 2x plus 3. Okay, I'll show you that one again. It's the opposite of x, to the power of 2, arrow over, minus 2x plus 3. Okay, and then you can graph it. Many of you are going to have your standard window. Remember, if you need your standard window, you're going to go to zoom, and then you're going to go to 6. So just zoom, 6, and it'll graph it for you. Now, picking out points from the graph like that is going to be hard to see because of the pixels. So here's the other cool thing I'm going to show you. So if you have your table, okay, in the middle goes the negative 1, 4, right? So I know that I have to go down to negative 2, negative 3, and then up to. I'm going to show you how you can check it on your graphing calculator. What does it say above graph? Table. So we're going to go to second table. So I'm going to do that again. Second table. And then this is likely what your table looks like. A lot of them are going to start at 0. You can scroll down to find what you're looking for. So if I want to know what the point is at -3, what is it? 0. Is that what you guys got when you plugged it in? Yay. Okay, what about -2? At -2, you're at 3. Our vertex is correct. And then we have 0, 3, and then 1, 0. Isn't that cool? Yeah, so you can use your table to find your points there, and that might help you when you graph. Okay, now when you graph, when you plot your points, okay, make sure that it's opening the correct direction. Also make sure that you have your axis of symmetry. Okay, so that's a dashed line. Feel free to do your axis of symmetry in a color, like on your homework, so it stands out. And then you have your vertex. Okay, and then I'm going to give you time to start your homework today, so I want you to do a couple things. I want you to do a couple problems. You can use the textbook here. Just make sure you put it back nicely. My tile's looking a little rough over there, okay?